Okay, lesson number 2 looks at equivalent forms of rational expressions. So if we start off with rational numbers and we use what we remember from rational numbers, we can then extend it to rational expressions. So if I have a rational number such as 10/15, how would I simplify 10/15? What would I do? So take a moment to simplify it, and then we can talk about how it's simplified. So one way that I could simplify this is I could divide the top and the bottom each by 5, which would give me 2/3. So that could be considered the process by which I divided the top and the bottom. And that would be in simplest form. I can't reduce any further because 2 and 3 no longer have any common factors. B says determine a second equivalent form of 10/15 and explain the process involved. So an equivalent form of 10/15 I could obtain by taking the top and the bottom and multiplying them by any number that I should choose. So I could choose to multiply both the top and the bottom by 2. If I look at that 2/2 that I've written, we know that a number divided by itself equals 1. So by multiplying this expression by 1, I actually haven't changed the value of this rational number. I've just changed how it looks. So this would give me 20/30ths, but this is still equivalent to my 10/15, and it's still actually equivalent to the 2/3. So if I multiply the numerator and the denominator by a common number, or if I divide the numerator and the denominator by a common number, I will get an equivalent form of a rational number. Now, another way that I could find equivalent forms is I could use factoring. So again, if we go to something like our 10/15, 10/15, if I was to factor it, if I was to look for numbers that multiply to give me 10, I could choose 5 and 2. Numbers that multiply to give me 15 would be 5 and 3. Again, 5 divided by 5 is 1. They cancel out, leaving me with the 2/3. This method of factoring and canceling out common factors is what we're going to use when we get into our rational expressions. So if I look at 18/42s, if I was to find equivalent form by dividing the numerator and the denominator, what number could I divide them both by? Now sometimes when the numbers get bigger, this can be a little bit tricky. So if you need to, keep it simple. What do you know you can divide 18 and 42 by based on the last digit in each number? They're both even numbers. I can divide them both by 2. So if I divide them both by 2, I get 9/21. Those are not even numbers, so I know I can no longer divide by 2, but could I divide by 3? I can, and I get 3/7. So I could simplify twice, okay? The other thing that I could do too is I could divide by 6 and just skip to the very end. The process isn't the important piece in this question. It's being able to successfully reduce to 3/7. And if that takes you 2 steps, then that's fine. Another equivalent form of 18/42 I can obtain by multiplying the top and the bottom by a common number. So I could multiply the top and the bottom by 2. So I can, in essence, double it. So if I double 18, I get 36. Double 42, and I get 84. And then the third method, factoring out and dividing factors. So I could take my 18 and I could write 18 out as 9 times 2, which I could then write out as 3 times 3 times 2. Well, why would I want to do that? Well, because when I look at 42, I think 21 times 2. And then when I see 21, I look at 7 times 3. So we call this type of factoring prime factorization because what I'm left with is prime numbers. 3 and 2s and 7s are all prime numbers. Then I can cancel out my common factors. 2 and 2, 3 and 3. Leaving me with 3/7, which is the same as what I got in part A. So what I would like you to do now is I would like you to do, excuse me, is I would like you to practice question number 2. Give yourself about 5 minutes and then move on to the next part of the video. So the next part of the video looks at equivalent forms of rational expressions. So we have 2 rational expressions, 2x over x squared plus 2x, and 2 over x plus 2. So what we need to do first is we are going to complete the table. We're going to substitute in these values of x and we're going to solve. So I'll do the first one with you as an example, and then what I'd like you to do is I'd like you to complete the chart on your own. So if x equals 1, I have 2 times 1 over 1 squared plus 2 times 1. So that gives me 2 over 1 plus 2, 3. If I look at the other expression, I have 2 over 1 plus 2, which also gives me 2 over 3. So what I'd like you to do is I'd like you to continue with that chart, and I'd like you to complete the next 3 rows. Okay, so if we look at our chart, the one thing that you may have noticed is in this first column, all of my rational numbers had to be, or rational expressions had to be reduced. So 4/8 became 1/2, 6/15 was 2/5, 8/24 was 1/3. Whereas the values in the second column did not have to be reduced. Now, what can we say about these rational expressions when x equals 1, 2, 3, and 4? Well, they're the same. When x equals 1, I get the same answer for each expression, right through to when x equals 4. These expressions are considered to be equivalent forms of a rational expression, and we can prove that. And we can prove that by simplifying the first expression. So if we look the steps, if we look at our 2x, what we can do with the denominator is we can factor the denominator. So what's common to x squared into 2x is an x, leaving me with an x plus 2. What I now can do is I can now cancel out factors. This x is a factor, and this x is a factor. That leaves me with 2 over x plus 2 as a final or an equivalent expression, which is the same as the second expression. So we say that this form, this 2 over x plus 2, is in lowest terms. At this point, I cannot cross the 2's out because I have to eliminate common factors, not common terms. The 2 in the denominator is attached to the x. So because it's attached to the x, I can only cancel out the factor of x plus 2. Okay? That's an important part right here. We divide out factors, we do not divide out terms. So now what we look at is we look at non-permissible values. So again, we have our 2 expressions. It says write the value as not defined if we can't calculate the value. So again, if I look at the first column, if I replace x with a 0, 2 times 0 over 0 squared plus 2 times 0 gives me a 0 on the top, but more importantly, I get a 0 on the bottom, which I cannot have, so I can say that this is not defined. Okay. If I do that to the second expression, I get 2 over 0 plus 2, which gives me 2 over 2, and I get a value of 1. So they're no longer equivalent for this value. So again, what I'd like you to do is I'd like you to pause, and I'd like you to finish up the next 3 rows, and then when you're done, you can continue on. Okay, so if we look at our results, what we notice is we have a couple of rows that are the same. Actually, all 3 of these rows, I get similar results, except for the first row. So if I was to answer the question, which values of x is the first expression not defined, that's at 0 and -2. If I look at the second expression, when is it not defined? That would be when x is equal to -2. So why do these numbers result in the expression not being defined? Because when the denominator equals 0, you cannot divide. And in each of these cases, these values create 0 in the denominator. Again, are restrictions. Okay? So it says in here, it talks about the fact that these 2 expressions have different non-permissible values. However, we can simplify this expression to become that expression. When we do that, we always have to list our non-permissible values from the original. So when I write out 2x over x squared plus 2x, and I write it in its equivalent form, it equals x over, or 2 over x plus 2. The stipulation is that x cannot equal -2 and 0, because these values make that denominator equal to 0. I'm not worried about this one, I'm worried about the original one. So it's important that you look at your non-permissible values before you start your simplification process. And that's what this says right here. So if we look at the next part, it says write an equivalent form of the rational expression by dividing both the numerator and the denominator and by multiplying. So dividing the numerator and the denominator, if I look at 8x, what can I divide 8 by? Well, I can divide it by 2, I can divide it by 4. When I look at the bottom, I would suggest possibly factoring the bottom. What do I know is common to 6x and to 4? A 2 is in common, leaves me with 3x minus 2 over 8x. From here, the 8 and the 2 can both be divided by 2, and I get 4 on the top. 2 divided by 2 cancels out, giving me 1. So I'm left with 3x minus 2 on the bottom. So I could divide the numerator and the denominator both by 2. But the thing to remember is if when I'm dividing by 2, each term was divided by 2, not just the x's. So if I multiply the numerator and the denominator, let's pick 3 this time. So if I'm going to multiply the top and the bottom by 3, three times 8x will give me 24x. 3 times 6x minus 4, I have to multiply the 3 by both terms, and I get 18x minus 12. Part C that says factoring and dividing out factors. So the denominator looks very much the same as what I did in A, factoring out that 2. In the top, I can also factor out a 2, leaving me with 4x. The 2's are what cancel, and I get 4x over 3x minus 2 for a final answer. If I was to list a non-permissible value for this expression, I would go to my 6x minus 4 and let that not equal 0. Move the 4 over, divide by 6, and then reduce. So in this expression, x cannot be equal to 2/3. So question number 3 says, which of the following are equivalent forms of the rational expression 6 over 2x minus 1? So what I need to do is I need to look at each expression and determine whether or not the expressions could be simplified. So if I look at the first one, what comes out right away is, oh, well, I could divide 12 and 6 by a common factor. And that is true. Or sorry, 12 and 4x by a common factor. The problem is I can't divide 1 by the same thing. So if I look at this, there's nothing more that I can simplify. This is in simplified form. So this is not equivalent. Okay. If I look at 2, if you notice the bottom, first of all, it's written backwards. So I'm just going to rewrite it as negative 6x plus 3. So all I did was switch the terms around so that it matches up with these terms. Now if I look at the bottom, I can take out a negative 3. So negative 6 divided by negative 3 gives me a positive 2x. 3 divided by negative 3 gives me a negative 1. And then on the top, negative 18, I could write as negative 3 times 6. The negative 3 factors will cancel out, leaving me with 6 over 2x minus 1, which is equivalent. If I look at 3, if I start off with that denominator, I have a common factor of x, so I could remove x from the equation. I would get 2x minus 1. On the top, that 6x squared, I could write it as x times 6x, because x times x is what gives me the x squared. There's my cancellation. But what is left behind is not equivalent because I've got this x in here. And then if I look at the last one, this one almost looks a little backwards. If I was looking at how do I go from this x to this 2, I could multiply by 2. And when I multiply by 2, I get 6 on the top, so we're okay so far. When I multiply the bottom, I get a 2x, that's good. But then I have to multiply this negative 1 by 2, which brings me to there, which is not the same as what I was given. So this would be a no as well. In class example number 4, I have two rational expressions, 4 over 2 minus x and 8 over 4 minus x. John substitutes x equals 0 into both equations, and this is what he gets. So it goes 4 over 2 minus 0 gives me 4 over 2, which gives me 2. And then he does the same thing with 8. 8 over 4 minus 0 this time gives me 8 over 4, which also gives me 2. They are equal expressions. Perfect. Is he correct? Well, try a different number. Try 1. If I put 1 into this equation, I get 4 divided by 2 minus 1, which is 4 over 1, which is 4. If I put it into the next one, I get 8 over 4 minus 1, which is 3. I no longer get equivalent expressions. Okay? Equivalent expressions need to be equal for the majority of values. Okay? Not just 1 or 2. So just because they're equivalent when x equals 0 does not mean that they're always equivalent. You have to check more than that. Or you have to look at the simplification. If I look at something like 4 over 2 minus x, yes, I can factor out a 2 from the 4 and get 2 times 2 over 2 minus x. But there's no cancellation that can happen. Because remember, I have to be able to cancel out factors. So this 2 minus x would have to cancel out with everything on the top. The same thing with here. Even though I can go 8 divided by 4 gives me 2, 4 divided by 4 gives me 2, they're linked to this minus x. So that's what you have to be very conscious of when you're working on these questions, that you're canceling out factors and not terms. So your practice questions, questions 4 and 5, and questions 8 to 10.